July 29, 2022. And I know it's been a while, guys, but let's do something in the Geo shed here. That's all Frida for detrital zircons. That's not what I'm going to show you. I want to elaborate more on the difficulties of just identifying rocks from pictures. If I held this to you, just took a picture of this like this, maybe sent you a couple like this, or maybe even with the 6-inch pencil for scale, which is about 15.2 centimeters, I think, or zoomed in and took a good picture of like this and sent that to you, what would you think this rock is? Most of you might sit there and say, oh, you know, it looks like a granitoid from some sort. It has a lot of mafics in it. Not quite at the 50% mark, but it does have a lot. And you might be like, oh, so that's some sort of maybe a granophyre, which is, granophyre is really on a rock type. They're kind of that between phase between like mafic and granitoids. Although if you plot most of them, they'll come out of quartz monzonite or a monzonite on the QAPF plot. And you might be like, oh yeah, that's definitely a granitoid. No, it's not. Now, I tried this already and I wasn't able to take it out. Continue guessing as you watch this video what you think this might be. Now, in the field, we'll use something like this. Now, when that says 10x, it doesn't mean 10x linearly. It's two-dimensional. So when it says 10 times, it's really lengthwise. It's only like zooming in three times the length of something. I think that's right. Yeah, close enough. Close enough. So, you know, I tried doing this to get you to see, and you can't really do it that well. So you're just gonna have to trust me on this here. And I'll use the pencil as a pointer, but I want to show you some stuff here. Now, this rock is not in context. It's pulled from it's a glacial erratic from Northwest Indiana. It was found in the till. I pulled it out. So you're looking at this and you might be like, yeah, that definitely looks like a granitoid, but let's do some analysis here. And I have looked at it with the hand lens, like I was in the field. I only use 10x. I do have stuff way better than that, but I'll just put that back when I can. But you know, I can't show that to you either. So you look at this, let's try to get it in focus here. I'm trying to keep the light on me. All right, you see, you turn it. Now, when you're looking at granitoid rocks, you often look for something that's called euhedral crystals. Euhedral crystals are basically ones with really good crystal facies. And in coarse-grained igneous rocks like granitoids or gabbros, that's common. And sometimes you can identify minerals without a hand lens if they're pegmatitic. But these are not euhedral. Now, you can get what's called anhedral crystal development in igneous rocks, which means poor crystal development. And the crystal facies tend to follow Bone's reaction series in, you know, ideal in a perfect world. They'll follow Bone's reaction series, which means your most anhedral ones are going, or your most euhedral crystals are going to be the ones that form first, your mafics. Okay, and as you go down to get to quartz, you'll often get quartz between like good feldspar crystals, just kind of blobular and just filling it in, you know. But you don't see that here with the quartz. You don't see that in the mafic minerals either. I've looked at this with the hand lens. Most of the mafics in here, these dark minerals, they are mostly hornblends and biotite. So we're lacking olivine and pyroxene, which is possible in an igneous granitoid rock, but isn't likely. I saw one greenish grain in here, but it's definitely a rounded grain of epidote, and that's key. You see, you look at a lot of these grains, even some of these mafic ones. Let's see if I can do this here. You look at some of these mafic ones. I don't want to give you guys a headache. And you can see they're rounded, sub-rounded or sub-angular. This looks granular. Yeah, you have some angular pieces, but then you look, where is it? I know it's big enough for you to see without this here. This is quartzite. You can see a weathering side right here, and this thing isn't angular, it's rounded, okay? And there's no bake zone around it. Now you can get things like xenocrysts in igneous rocks, but this isn't that. See how it's rounded? It's not the only large rounded grain on here. There's a couple feldspars that are relatively large. See if I can do this without blocking you. Here's a good one right here. Yeah, the pinks are pretty much K-spar in this. There's some pink plage in here, but not a lot. This stuff is mostly K-spar. See how it weathers? Now, let's go back here, because this is the most weathered side that shows you these things. Oh, there's a good one there too. So you have a granular rock overall. This, now you do see some angular bits, but that's to be expected in something we used to call a gruss. Basically, a gruss is a sandstone, because remember, sandstone has to do everything with grain size and nothing to do with composition, because you can have quartz sandstones, you can have feldspar-rich sandstones, arkoses, or you can have ones made of rock fragments, which we just call lithic. But you look at these, and gruss basically is sand that would form near the source. Like if the source was a granite or a gabbro, and it's just like not that far from it. And this very much resembles an arkosic lithic arenite, or a grussic type material that formed not that far from wherever it weathered from. And we have a lot of mafics weathering out from here, and you might be like, well, maybe the olivine and pyroxene's weathered out. But where is it? I think it's right. I tried to, yeah. You see some biotite crystals in here that are partially weathered, but so that tells me that probably pyroxene and biotite has strictly weathered out of here after this formed. Any olivines or pyroxenes probably weathered out before this rock even started becoming sand. Because remember, Bones reaction series, mafic minerals form first, they weather first. They're not stable at Earth's surface. Is there anything else that might key us into the fact that this might be sedimentary, or in this case, probably metasedimentary? And yes, see if I can get it to balance here. Let's put it on here. Try to do this a little bit. We see some relic sedimentary structures in here. We can see the relic bedding in here, and almost cross bedded. You might be like, well, that's foliation. Well, foliation doesn't tend to form things that look like cross beds. So the more I look at this, the more I'm coming to the conclusion that, yeah, this thing is a meta arkosic litharenite. It's a sandstone. That's mostly coarse, but it is a sandstone. There are some grains in here, and the mafic ones are also more rounded. The smaller ones are more rounded. We got some, the big ones are too. Now, usually you can tell, you know, coarser grains will be less rounded than finer grains in a like nice marine setting, because the finer grains have been transported more usually. So this tells us that this did not form in a marine environment. If it did, it formed real close to some sort of granitoid cliff or something like that. Now, so this, to me, unquestionably, after looking at it a little bit, I could do scratch tests and something else, you know, and stuff. And just with a 10x, I do have hand lenses, or not hand lenses, but microscope that can do 900. And I could tell you for sure, but I'm 95% confident this is a sandstone, metasedimentary rock, a sandite, if you will, that, you know, formed from nearby stuff. Now, you got to remember too, plus this kind of ratio is relatively rare, where you see a lot of mafics like this, not enough to the 50% mark, and you have a lot of K-spar, but only a little bit of plagioclase. I mean, obviously cyanites are like that, but there's a lot of mafics in here, and like I said, granophyres are like that a lot. Remember, can't be gabbros. Gabbros, by definition, have almost no K-spar in them. They're basically, if you take out the mafics, you know, your mafic dark minerals in a gabbro, you're basically left with plagioclase and maybe a tiny bit of quartz or a tiny bit of trace feldspathoids. So, you know, there wasn't derived from any sort of gabbro in entirety. It probably was some sort of granitoid or granitic rocks in the area. So yeah, the fact that our grains are well, I mean, there's some angular ones, but sub-rounded to rounded. The fact that we have relic sedimentary features in this, our mineral ratios, the fact that our finer mafic rounded grains, that we have finer mafic rounded grains as well as coarse, you know, rounded felsic grains, in that case the quartzite, you know, but we have some feldspars too, tells us that this is a hodgepodge mixture. Didn't form in a marine environment, or if it did, it was like on a beach in a cliff somewhere, something like that. Probably a stream environment is my guess, near its source. So that's what you got to look for, and it's something that experience and education can only bring you. It's not something that you just fumble your way around to get. All right, so I think I'm going to cut this off here. It's past 11 minutes. But, well, no, I won't. I just want to take you through the lab here a little bit, too. But essentially, that's all about this rock. You can see these are all sandstones, too. Frida sandstone, mostly. You know, there's my detrital zircon bags there. And I got a lot to talk to you guys about the Frida sandstone, even though I know most of you think it's boring. Hopefully I can get back in here sooner than later, since fall's coming up and we'll be back from Greenland then, and I need to finish all this stuff. So, oh yeah, this is one of those digital microscopes I use. This one's broken. Anyway, I just thought I'd show you, let you guys know it's still here. That's in Fahrenheit, so it's a nice day today. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something.